Okay, we're on lesson 41, unit 7-5, page 456, part 2. We're solving trigonometric equations. Now, what it wants us to do here is to solve each equation for all real values of x. This is the homework sheet that we have. We want all real values. That means we include the plus pi k or 2 pi k or pi over 2k, that thing. We want all possible answers. It's limited our answers before to 0 to 360 or 0 to 2 pi. When it said 0 to 360, we wrote it in degrees, and when it said 0 to 2 pi, we wrote it in terms of pi. Here, we're going to write it as the set of all, and we're going to go ahead and write it in terms of pi. So our first thing we would do is kind of begin to think about this situation, a smart trig class. And we're going to think about where is sine negative at, because this was a negative 1/2. And we would know that sine would be negative in these two quadrants. So whatever we do, we're going to have those two quadrants. Now, that tells me that there's going to probably be two pieces of my answer. There's going to be the answer that's in this quadrant, around and around and around. And there's going to be the answer that's in this quadrant, around and around and around. So I'm going to have the stuff that's in quadrant 3 plus all the way around, you see? And then I'm going to have this angle that's in quadrant 4 and then all the way around. Y'all kind of understand that? There's two pieces. Sine is negative in quadrant 3 and 4. And whatever angle I get in quadrant 3, I'm going to have that every time I go around, 360 degrees. And then I'm going to have another one over here in quadrant 4, and I'm going to go around and around with it. Now, what reference angle actually is attached to 1/2? Sine of what's a half? Well, it's 30 degrees as degrees, but it's pi over 6 in terms of pi, right? Now, this is pi, which is 6 pi over 6. I agree with that? Understand that? And this is 2 pi, which is actually 12 pi over 6. Now, to get the reference in quadrant 3, we need to be one more sixth past 6/6, which would put us at 7/6 pi. And then the plus 2 pi k around and around and around and around. When we're in quadrant 4, we want to be 1 pi less than 12 pi over 6, which would be 11 pi over 6. And then around and around and around and around. So this is the set of all values of x that would make that true. Let's see how we got that. So you really have to know your unit circle. I mean, that's what this is mandating, you know your unit circle, basically. Understanding reference angles, what's positive and negative where. You got to know some fraction stuff so you can get those denominators in there and add the half and the sixth and subtract the sixth and that kind of thing. All right, any questions on number 7? All right, number 8. I'll just recreate this for number 8. Number 8's a little harder. One of the things that some of you are trying to do, and I'll talk about this after the recording's over some more, is you're hoping that what's on the test looks exactly like what's on the homework so that you can memorize the process for that problem and repeat it. That's not what we're trying to do here. We're trying to learn how to simplify expressions. And so we're going to have to learn a general process that's based on the order of operations all the way back to Algebra 1, simplifying expressions and solving equations. We're really doing algebra. So what y'all are missing is you're trying to do picture memory on how to solve a problem, and you're not thinking about the order of operations and how algebra is involved. The algebra is what's bogging you down. and then the not knowing your unit circle memory work is bogging others down. Let's just look at number 8. We have 3 tangent square x is equal to square root 3 tangent x. Now that obviously could be intimidating for some folks. Remember that we decided in an earlier video that we really don't want to divide by tangent x if we can help it, because that's gonna factor an idea out. If we divide out something, we're not getting as good a picture as what's going on. So we begin to think, I have a square and I have a to the first power. Now what that tells us from algebra is this is a quadratic situation. And we're going to treat it like it's a quadratic. So you got to leave trigonometry and start thinking algebra. If I have a square, a second power, and a first power, that means I have to set it equal to 0. That's what we do when we solve quadratics. We set it equal to 0. So we're going to go minus square root 3 tangent x. Minus square root 3 tangent x. You may say, well, how'd you know to do that? Because I know algebra. I know when I have a square and a first power, I have a quadratic. And before you solve a quadratic by any method, you must first set it equal to 0. It says that on page 223 of my Algebra 1 book, word for word. All right, so we're going to have 3 tangent square x minus square root 3 tangent x is equal to 0. So we're going to set it equal to 0 and then solve. Now, in my Algebra 1 book on page 213, it teaches you how to do the AC method of factoring. And then on page 215, A, B, and C, it says, what do you do if there's a B and C part? What do you do if there's an A and B part? What do you do if there's an A and C part? What do you do if there's an A, B, and C part? Well, I think it's example 3, page 215A, if I'm correct. And it says, what do you do if we have an A part, the square part, and a B part, the to the first power part, and you don't have a C part? Remember what we did? We factored out the common factor. And we would end up with a monomial times a binomial. And we would set each one equal to 0. If you had an A, B, and C, you end up with a binomial times a binomial. What can you factor out of those two things? Tangent x. So then we think tangent x times what is 3 tangent square x? 3 tangent x. This is plain old Algebra 1. And then we think tangent x times what is negative square root 3 tangent x. Tangent x times what is negative 3 square root, negative square root 3 tangent x, negative square root 3. So we said, oh, I've got a quadratic. I have to set it equal to 0. I've got an A and a B. I don't have a C. I'm not going to use the AC method. I'm going to factor out the common factor, which gives me a monomial times a binomial. And if these two things have a product of 0, then either the first one is equal to 0, or the second factor, 3 tangent x minus square root 3 equals 0. If those two factors equal 0, the product of those two factors is 0, then either one or the other or both of those factors is 0. Now this one's already ready to go. Tangent what is 0, and we go back to our unit circle, A, smart, trig, class, but we want 0. The tangent of what is 0? The tangent of 0 is 0, and the tangent of pi is 0. Now, where do we start? We start at 0. That's the first time that the tangent of something is 0. And then we want the plus pi k or the plus 2 pi k. How far do you have to go until you get 0 again? Only pi. You don't have to go 2 pi. So you're going to have plus pi k. Now, we know that 0 plus pi k is pi k. So the tangent x portion lets us know that every pi k, there's an answer that'll make that true. Now we got to look at the other part. On the other part, we have multiplication and subtraction, and we're going to undo in the reverse order of operations. Sally, dear, my excuse, please, all that good stuff we learned in Algebra 1, page 33. And so we're going to add 3 to both sides. And we're going to have 3 tangent x equals square root 3. We're just getting the junk off of x. Now we're going to undo multiplication by division. And we have the tangent of x is equal to the square root of 3 over 3. And we need to know when is the first time that's true, and when is it going to become true again, around and around and around and around. Now, when is the first time that tangent x is positive? Square root 3 over 3. 30 degrees, pi over 6. 30 degrees, pi over 6. Square root 3 over 3. The tangent of 60 is square root 3. Tangent of 30 is smaller, square root 3 over 3. Remember that? So the first time this happens is at pi over 6. Now, where's tangent positive again? The quadrant across from it. So how far do we have to go to get there? Only pi plus pi k. So we have pi k, and we have pi over 6 plus pi k. Any questions on number 8? Some of you are bogging down because you're trying to make one problem look like another. You have to, once you get going, you just use them plain old Algebra 1. Plain old Algebra 1. Okay? I'm going to stop the recording there, and then that's all of it for 41. But then again, in class in a moment, I'm just going to maybe, if you have questions, I'm just going to work them up here so everybody can see that. Okay?